All right, so now let's talk exponents. And the good thing about exponents is we have laws and rules that dictate how we work with them, and we're going to go over that right now. Obviously, the most important thing that we have is we actually have this guy here. Okay, he's our little chart, he's our cheat sheet. He's going to be the one that tells us, what to do. And if you are not sure, just always reference back to him and see if your problem looks very similar to something that we have on here already. Okay, so the first law, right? If we have two things that have the same base and they have different exponents, well, then we just take and we add those, we combine to one base and we add the exponents. Okay, what does that look like exactly? Well, that's when we have like 2 cubed times 2 to the fourth. What we end up doing is combining that to one base of 2, and then we add the 3 and the 4 to get 2 to the power of 7. In this case, we work it out to get 128. If you're wondering, well, that looks like we have that's a lot like saying x to the power of 3, y to the power of, no, sorry, same base, x to the power of 3, x to the power of 4. Well, then we just take and go x times x to the power of 3 plus 4 gives you x to the power of 7. All right, anytime our exponents are separated by a parentheses, well, that just means that we're going to actually multiply the two numbers outside or with the parentheses. So we're going to multiply. If we have 2 to the power of 3 to the power of 4, so 2 to the power of 3, or 2 cubed raised to the power of 4, well, then you just take and multiply that 3 times 4 to get 2 to the power of 12. Again, that is like saying x to the power of 3. Again, we have a parentheses, raising that to the power of 4. Well, just multiply the 3 and 4 to get x to the power of 12. All right, anytime we have different bases, we have a times b, both raised to the power of n. Well, then we distribute the n to both of them. Okay, I don't like the example given. I'm going to give you an example. If we had x times y in parentheses and we raised it to the power of 3, well, then I have to take that 3 and distribute it so that I get x cubed, y cubed. This also works if I had 2x, sorry guys, 2x raised to the power of 3. Well, then I, again, distribute it to both of them so that I get 2 cubed x cubed, and I work that out to get 8. So the 8 times x cubed. Okay? Now, again, anytime we have a fraction, again, we take the exponent and distribute it to the top and to the bottom. Okay, so I like this example. We have 2 over 5, both raised to the power of 3. Well, I take that 3 and I'm going to go 2 cubed and 5 cubed, and I'm going to get 8 over 125. Now, anytime I have a fraction where they both have the same base, what ends up happening is I take and I end up subtracting the exponents. Again, you have to have the same base in order to do this. Matter of fact, the best example I can give you is you already work with things kind of like this. If we had x squared over x, right, that reduces down to just be x. But in reality, what you're actually doing is this is like an x raised to the power of 1. And what we end up doing is we go, oh, okay, well, we're going to move that to the top by subtracting him to the other side so that we end up with just x over 1. And then this becomes just x to the power of 0, and anything to the power of 0 is 1. So it just ends up being x. Now, anytime we already have a fraction, but say the larger number is on top, or the larger exponent, sorry, is on the top, then all we have to do is take it and move it to the other side of the fraction by making it the opposite sign. Okay, anytime you are moving an exponent to the other side, you make it the opposite sign. So the given example is we have 2 cubed over 2 to the 5th. The bases are both 2's, so I know I can combine the numbers. But I will take and move the 3 down to the denominator because he is smaller, so he moves to the bigger exponent. And I change the sign by then saying 5 minus 3 so that I get 1 over 2 squared, and that simplifies that to be 1/4. Now we can talk about this all day long, but the best way to really go into it is to do it. So let's look at it. Oh, there's one more thing that we have to go over. We do have an exponential expression. We know that it is a to the power of r, meaning r is any exponent. And we can deal with negative exponents. Anytime you're given a negative exponent, we don't like negative exponents. We do not want to we never give answers with negative exponents. We always try to make them positive. Now remember, if I have a negative exponent and say it's on its own, then I'm going to take and I'm going to raise it to the power of 1, because then I'm going to move that a to the power of negative r to the other side and make the exponent a positive. Again, you don't know it until you do it. So if we look at it, if we have 4 to the power of negative 1, to make him a positive exponent, I have to then take and make that 1/4. That then, by moving him to the other side, that becomes 1 over 4 to the positive 1. Again, it's like taking him, putting him over 1, making him a fraction, and then moving the 4 to the other side. Again, for b, right? I make him into a fraction, and then I make him positive by moving him to the other side. And that becomes a positive 2 to the power of 1. But I don't do exponents of 1. He's an understood one. For c, again, I don't like that negative 2, so I have to move him to the other side. So I get to do 1 over 2 squared, but I like him reduced, so that becomes 1 over 4. D, again, I have 5 raised to the power of negative 1. I don't like negative exponents, so I move the 5 to the other side, and he becomes positive 1. E, same thing, except this is to the power of negative 2. I move him to the other side, so I get 1 over 5 squared. That becomes a positive 2. And then I do the math, and I get 1 over 25. Now, this is what happens when the negative exponent is right beside the number. But sometimes the exponent is outside of a parentheses. When he's outside of a parentheses, it means I'm going to flip the entire problem. All of it. Everything that's inside the parentheses will get flipped. So I have 1/2 raised to the power of negative 1. Don't like that negative 1, so what I have to do is take and flip it so that I get Sorry guys, my computer shut down for just a moment. Let me pull my screen back up, make sure it is all good. And we're going to go back to our exponents. Okay, so to get rid of the negative 1, there we go, second quit. We will take and flip the entire fraction inside. So we end up with a 2 over 1, which is of course just 2. All right, for B, again, we have 1/3 raised to the power of -1. Don't like him negative. I know I'm going to flip it so that it becomes 3/1 or just 3. C, this one's a little different, okay? I'm going to flip him so that I get 3/1. And flipping him does make that a +2, but we still have to distribute that 2 so that we end up with a 3 squared over, well, of course, a 1 squared, which is 1, but 3 squared, which is 9. Remember, I don't do understood ones. I just leave them as a whole number there. All right, D, I have 4/5 raised to the power of -1. I don't like them negative, so I'm going to take and flip him so to get 5/4, and that -1 then disappears. For E, I have 1/2 raised to the power of -2. Again, I flip, so I get 2/1, but he is a square, so I have to distribute that square so that I end up with just 2 squared, which is 4 as an answer.